So now, built on our axiom, let's derive a formula that we have been using from past 2-3 years. So the heading is probabilities of event in equally likely outcome sample space. So first let's talk about equally likely outcome. What does that mean? In simple words, each outcome is in your experiment has same chance of happening. Or we can also tell it as all outcomes with equal probability. Like tossing a coin in a fair, tossing a coin and getting a head or a tail. They're equally likely. A match between a team which is very strong and which is very weak, not equally likely. So we're talking about a scenario wherein this or that, there's equal chances of happening. Okay, yeah. Now, probability of a single outcome. First, let's build on this. Probability of a single outcome. In this scenario, what is the probability of a single outcome? So for a finite sample space with equally likely outcome, if we have the sample space to be omega 1, omega 2, omega 3 and so on and so forth of n elements, right? And if each of them, the probability is p, some value p, it's between 0 and 1, then we know that probability of a sample space will be equal to 1. Probability of sample space can also be written as omega, or let me put it this way, probability of omega 1 plus probability of omega 2 plus so on and so forth, probability of omega n. All of them put together is equal to 1. But each of them is equal to p. Is it not? Because they are equally likely to happen. Now, there are n of this. There are n of this. There are n of it. N times. So p plus p n times is what? Np, which is equal to 1. So therefore p is equal to 1 by n. Right? Now, probabilities of event in equally likely outcome sample space. What does it mean now? So this happens to be something like this. If S is the sample space and E be any event such that n of S, that is the number of sample space is n, and the number of elements in event E is m. In each outcome, if each outcome is equally likely, then the following can be concluded. The probability of E, that's the event happening, is equal to, yes, m by n. What is this formula? You guys have been learning this from past 2-3 years. The number of favorable outcomes favorable to us. Remember this. So all of that axiom and everything, it leads to this particular formula which you guys already know. Not a big deal, right? Divided by total possible outcomes. So this formula is valid. It's actually probability of event in equally likely outcomes. When things are not equally likely, then this is not applicable. So we have a finite set. If the total elements is n and the number of elements which is favorable to us is m, so it's m by n, right? So this is the derivation towards that. Okay guys, again, it might look thoda fancy and it might not make sense, like why are we doing this, but this is how the math is built on. First they have axiom, on that we start building our concept and then the formula. That's how this generally works. Okay, so this is just an introduction. There are many such things, not in this chapter, in general I'm talking about. Anyways, pause and have a look and do copy.